let us see what is a stable system. So for example, let us consider a concave container. So this is a concave container. On this we are considering a ball. So if we apply any disturbance force externally to this ball, so this ball is displaced by a force. So it will roll towards left as well as right if we apply external force to this. So it will roll back to its equilibrium state again after some time. So that is, initially it was in this place at, let us consider at t equal to 0, the ball is at the equilibrium state and it is on the concave container. So once we apply force to this ball, it will roll back and come to the same state. So it is a stable system. Input also same, the output is also same. So both are bounded, both are limited. So we can consider this system as stable system. Next, in the second example, let us consider a different surface. Here the ball is placed on this curved surface. So initially it is at the rest at some point. Here also we can call this as an initial time, that is t equal to 0. This is the equilibrium state. Once we apply force on this ball, it won't come back to original place, it will roll down or it falls down. It will never come back to the same equilibrium state, that is t equal to 0, depending on this different surface. And this type of system is called as unstable system. So here initially input was bounded, it was at equilibrium state, but the output is not the same as input. It is not in the same equilibrium state, it is going to infinity. So it is called as unstable system. Next, third one is critically stable or marginally stable system. Here we are considering the plane surface. We are considering this ball on the plane surface. Once we, initially it is at the equilibrium state, it is not moving, it is at the rest. So once we apply the external force on this ball, it rolls to some fixed distance. So it will move from that place to this place once we apply the force on this. So it is changing its position. You are not getting the initial, that is equilibrium state, that initial state, but you are getting some value that is also finite but not the same as input. So this is called as critically stable or marginally stable system. So these are the three examples to define stable, unstable and critically stable systems. So let us see what do you mean by stable system according to control system. When the system is excited by a limited input, the output is also bounded and controllable. Here the input is force, you are applying the force. So initially it changed its position, later it comes to the same position. It was bounded. It is not going beyond the limit. It is in the limit itself. So in the absence of input, if you won't apply any force on this ball, it will be in a same state, that is 0 state. So a linear system is stable. So if you consider S-plane, that is frequency domain graph, consider the number of roots. So in the transfer function you will be getting numerous roots that may be zeros or poles, that is the roots from numerical parameter polynomial or denominator polynomial. You will be getting the roots. If the location of that root, if you find those roots in the left side of the S-plane, that is in the negative side, if you find the roots in the left side of the S-plane, then the system is said to be stable. For unstable system, the input is limited but the output is limitless. It is unbounded. It is not a bounded input and bounded output system. It is just input is bounded and output is not bounded. Output tends to infinity. Only input is limited. In case of frequency domain or S-plane example, if you find the roots in any transfer function, you are going to find out the roots, that is poles, the roots of the given polynomial and in the transfer function. So there are two cases to find out the system is unstable. So one is at least one pole must be present in the right half of the S-plane. So this is 0 point, that is origin. To the right side of this, any pole should be present. In the right side of the S-plane, if any pole is present, then the system is said to be unstable. And also the second condition is if multiple pole, or you can say that it is a repeated poles. For example, S equal to 0 is one pole and also S equal to 0. So in this graph we have two poles or two roots and the origin, that is on the imaginary axis. J omega axis is the imaginary axis. On this imaginary axis, if the repeated roots S equal to 0, S equal to 0 is the repeated root. If multiple repeated roots are present on this imaginary axis on this S-plane, then we can say that given transfer function is unstable. So these are the two conditions to say the system is unstable. Next is critically or marginally stable system. So here no pole should be present to the right side of the S-plane. If any pole present on the right side of the S-plane, then it will become unstable system. Here there are no poles present to the right side of the system, and also multiple poles, but it should not be repeated poles. So multiple poles or individual poles present on the j omega axis, that is imaginary axis, then we can call this system even the number of poles present on the left hand side. So one or more number of poles, but it should not be repeated. If those poles are present on the imaginary axis, then we can say the system is critically stable or marginally stable system. So we can see the difference between these stable, unstable and critically stable systems. First, in the stable system, all the poles should be present in the left hand side of the S-plane. So this is x-axis and this is y-axis, imaginary axis. So all the poles should be present in the left half of the S-plane. So it is a stable system. And for unstable system, only at least one of the pole or one of the root must be present in the right half of the S-plane. So one pole is present here. So it is unstable system. One or more number of poles can be present in the right half of the S-plane along with the poles in the left half of the S-plane. So this is called as unstable system. And also for unstable system, this is multiple repeated roots are present on the imaginary axis. So at least one pair of repeated multiple poles so should be present on the imaginary axis. Then also we can say that the system is unstable. And critically stable system. So here no root should be present on the right half of the S-plane. So there are no roots here in the right side of the S-plane, and also the poles should be present on imaginary axis. So but not the repeated poles are here. There are three roots are present on the imaginary axis, but they are not repeated. They are not the same values. They are different values. So they are present on the imaginary axis along with the leftmost roots. This is called as critically stable system.